Jai Hind everyone. Today we are going to discuss the topic that is structures in C. Up till now, we had a discussion on the arrays where we had a group of variables, or we can say a collection of similar data types we have seen in the case of arrays, right? Like if I declare an array of integer type, then it is mandatory that it is going to have all the elements of similar data types only. That means each and every array element will be of this same data type, right? But there may be some of the cases where we can have a situation where I need to keep a record of the books, maybe a record of students, where the collection of dissimilar data types I am going to have. That means if I am going to have a record, student record, where I am having the student name, student number, student fee, and so on, where name, that is of type character, this is of type numeric, say either integer or any kind of numeric we can take. Then student fee, it may be a floating point number, right? So the answer is structures. If we need to keep a record of dissimilar data types, then we can create a structure in C programming language, right? So let me start. We have seen how ordinary variables can hold one piece of information and how array can hold a number of information of the same data type, right? Here we can see all the elements are of same data types, fine. But quite often we deal with the entities that are the collection of dissimilar data types, right? For example, books and books records, right? So construct, one option we have, that is construct individual array, one for storing name, another for storing prices, and still another for storing number of pages, right? That's what we can do. Like over here, one is name, book name, second I do have a price, third I do have pages. I have taken three different arrays of three different data types, say name is of character type, price is of float type, and pages, that is of integer type, right? Now we can read out the name, price, and number of pages of three different books, right? So we have applied a loop from 0 to 2, that is 0, 1 and 2. 3 times it will be there, it will be running, and it will ask to give input for the three different books, right? And then we can print the number of pages, number of what is the price of the book, and similarly the name of the book, right? But if I want to have a complete record, say I'm going to have the record of 5 books, I'm going to have a record of 100 books or 500 books. So it becomes a very tedious task if I do consider the different array names, right? In this example, if I need to keep the record of say 100 books, then the record of book 1, the record of book B2, B3, B4 and so on, it will become little bit complex and tedious task to manage this without using structures. While using structures, we can easily create a complete record of a book. For example, I am taking 3 structure elements, say one is name, one is price and one is pages. What we are going to do? We are going to design, or we are going to declare a data type of our choice, right? That's why it is known as user defined data type. That means user can define its data type by its own. What elements I'm going to have? I'm going to have 3 elements: name, price and pages. Name, that is of type character, price, that is of type float, and pages is that is of type integer. Now I'm going to declare the variables of this data type. Which data type? What I have created? I've created a structure. For that, I must need to use a keyword, that is a struct. Struct keyword will be used. Struct book. This is the keyword which tells the compiler that I'm going to create a structure. I'm going to work on a structure. Struct book, that is the name of the structure which I'm going to create. Then these are the structure elements. These are the structure elements, right? Now I'm going to declare the variables of data type struct book. Okay, B1, B2, B3. What are these variables? These are the variables of type structure. Which structure? Book, which I have created over here. Fine. Now how I can read the record for this book? For that, we use dot operator. We use dot operator, right? Initially, we will be having structure variable dot structure name. It is mandatory to have a structure variable before using the structure element. Okay, that means it says enter the name, price and number of pages of 3 books, right? When I'm writing %b1 dot name, b1 dot price, b1 dot pages, that means I'm asking a user to give an input for the name of book 1, price of book 1, pages of book 1. Similarly, another variable b2 dot name, right? That means name of a second book, name, price of the second book, pages of the second book. Similarly, b3 dot name, that says just give an input for the third book, name, right? Then price of the third book and pages of the third book and so on. Right? So it is important to note then that if you are using structure element, that is, for example, say price, it is mandatory to have a structure variable dot structure element. Then only we can access the structure element, right? Okay. If you want to print these values provided as an input by the user, simply we can use a printf statement and then b1 dot name, b1 dot price, b1 dot pages, and similarly for the other books, right? So here we can see b1, b2, b3 can be declared to be of type struct book, right? These are some of the methods of declaring a structure. First of all, we need to keep this thing in mind that struct keyword will be used before structure name, right? Struct book, then opening and closing curly braces. Within this body, we will include the structure elements. Fine. Then either you can place a semicolon here and then again we declare the variable structure variables like this: struct book b1, b2, b3. We can declare the structure variable in a similar manner likewise we do with the ordinary variables like integer, pages, float, price, character name. Here, what is the data type? Struct book. Struct book is a data type and we are declaring the variables of this data type, right? What is another method? We can also do like this, say struct book character name, float, price, integer pages, there is a semicolon, yes. Now, closing parenthesis, then declare the structure variables, say B1, B2, B3, and then place a semicolon. This will work exactly like this, right? So, there are a number of ways to declare the structure variables. Fine, or like this. There are these two ways which we have discussed. So, structure variables can also be initialized where they are declared. Fine. Likewise, in the case of array, we have seen integer a. Suppose a is an array name and I have initialized the values like 10, 20, 30. In a similar manner, we can initialize structure variables, right? Like we have declared a structure, struct book, and these are the structure elements. Now I am declaring variables of structure book and also I am going to initialize these values, right? Within the curly braces, we can initialize the value of the structure variable. What is the structure variable? B1. B1 equals to first one. What is that? That is name. Okay, because it is of character type, that's why I have included this within the single quotes. Then this is a float type. Okay, the value of price, and this is what? Number of pages, right? It is important to understand that a structure type declaration does not tell the compiler to reserve any space in the memory. While we are declaring the structure type declaration, it does not tell the compiler to reserve any space in memory. Then how a compiler is able to understand what amount of memory it is going to store, it is going to consume? All a structure declaration does it defines the form of the structure. Then it will be able to understand, okay, how many variables are there, accordingly it will be going to consume that much amount of memory. For example, if I take the example of this B1, it is having one element of type character, another is of type float, another is of type pages. Accordingly, it will calculate what amount of memory it is going to occupy, right, and so on. Fine. So, that is just a simple example again how we can initialize the value of the variables like B1 equals to this, B2 equals to this, and so on. And similarly, we can simply display these values by using printf statement. How we will be using? With the help of dot operator. How we will be using the elements, structure elements, structure variable dot structure element, right? Structure variable, for example, B1 dot structure element. Similarly, B1 dot price, B1 dot pages, and so on. Fine. So, this is what about the memory representation of the structure variable. For example, I told you in the last slide, B1, say I am having a character array of length 20. If I say character takes 1 byte, right, then it is going to occupy how many bytes? 20 bytes, right. Then second, if a float is taking 4 bytes, it is going to consume 4 bytes over here. Integer, if it is taking 2 bytes, it is going to consume 2 bytes over here, right. So, that is how these values will be initialized and will be allocated to the variable B1, right. Some important point in the case of structure. In array, we can access the individual element of an array using subscript. What is a subscript? This is a subscript, right. That means I have declared an array of type integer where it is going to contain 10 elements, right? So how we can access? With the help of subscript. Suppose if I want to access the first element of this array, I can write A0. Because indexing starts with a 0 in C. So we can write A0 to access the first element, A1 for the next, and so on, right? So in arrays we can access the individual elements of an array using subscript, but structures uses a dot operator, right? Like we have seen in the previous slide, p1 dot name, right? A structure variable dot structure element. Before the dot operator, there must always be a structure variable, as I told you in the last slide. It is mandatory, right? And after the dot, there must always be a structure element, fine? B1 dot name. What is B1? Is structure variable. Name, what is that? A structure element, right? Okay, up till now we have seen how we can take, how we can use the arrays, how we can use these structures, and now we will see if we are going to store the record of say 100 books, then how we are going to do that. In the previous example, we have seen that we can store the record of say 3 books, right? B1, B2, B3. We have taken 3 variables, right? 3 structure variables. But what in the case if I'm going to have the record of 100 books? So the answer is array of structures, right? That means we can declare an array of type book, of structure type book, right? So we have again declared the same structure, struct book, all the elements of this structure. Now instead of declaring the variables like B1, B2, B3, I'm going to have a record of 100 books. That's why I have taken a array of 100 books for the 100 books, right? So that is quite simple. How I'm going to read the value of 100 books? Simply I'll be applying a scanf function, and here I will include variable name dot element name. When I'm going to read the record for the 100 books, that means I'm going to repeat the same statement 100 times. So that is quite obvious to use a loop, right? So I have applied a loop from 0 to 99, right? And then we are just reading out the record of the 100 books. When the value of I is 0, initially I have initialized the value of I as 0. When the value of I is 0, B0 dot name. That means enter the name of the first book, enter the price for the first book, enter the pages for the first book. When the value of I becomes +1, right? Initially it was 0, next time +1 it becomes 1. That means name, price and pages for the next book. Again incremented by 1, name, price and pages for the next book, and so on, right? So likewise we are reading out these values. Similarly we can print these values. Simply we will be applying a loop, and then easily we can display the records, these records, right? So this is what array of structures, how we can use the concept of arrays within the structure. Here we have some additional features of a structure. The values of a structure variable can be assigned to another structure variable of same type using the assignment operator, right? How we can do that? Suppose we have declared 3 variables, one is E1, one is E2, one is E3. Of which type? Of type structure, employee structure. We have created an employee structure, struct EMP, and here we are having the structure elements as name, age and salary, right? So we have declared 3 variables of this structure employee E1, E2 and E3, where I have initialized the value of E1 as name, then age and then salary. Now what I want to do, I want to keep the copy of this record into another variables as well. So how we can do that? We are having two options. One is copying one by one element, right? So as we had a discussion in the while we have discussed the string strcpy, that is a string function to copy one string to another, right? So we have used strcpy function to copy name of employee 1 to employee 2, right? The name of employee 1 will be copied into the name of employee 2 variable, right? Now next we have written E2 dot age is equal to E1 dot age. That means whatever the value of E1 dot age is, that will be assigned to E2 dot age. That means employee 2 will also be having the same age as of E1. Similarly, E2 dot salary equals to E1 dot salary. We should keep this thing in our mind. Whatever value we are going to assign, that will be there at right hand side, and the variable to which we are going to assign, that will be there at a left hand side. Fine, that is most important. Okay, that is what? Copy one by one. But what in case if I want to copy the entire value at a one go? Copying all elements in one statement. Simply, nothing we have to do. Simply just write E3 equals to E2. Whatever the value of E2 is having, all the values will be copied to E3. As simple as that. Right? So now if we want to display the value of all these elements, right? So simply we will be using a printf statement, E1 dot name, E1 dot age, E1 dot salary, then E2 dot name, E2 dot age, E2 dot salary, and then E3 dot name, E3 dot age, E3 dot salary. What value it is going to print? Yes, because we have copied this value to all other elements as well, variables as well. So it will be having the same value. Okay, now we are going to discuss nesting of structures. Likewise, we have seen in the case of for loop and the control statement. Similarly, we can have structure within a structure, which is known as nesting of structures, right? One structure can be nested within a third, that is address, right? In the address structure, I have taken 3 elements. One is phone, city and pin, right? Another structure I have declared, that is of type employee, and within this employee structure we have name, age, salary and here I have declared a structure variable of structure address, right? So if I declare a structure variable of employee structure variable, that is E1, how many elements employee structure is having? Name, age, salary and address. Fine. So that's how we can initialize these values. Fine. So in this way we can have a structure within a structure, right? In fact, we can also pass the structure variable to a function. Likewise, we have seen we can pass a normal variable to a function, like function A. Suppose you are calling from main. So here integer x and then say x plus plus and so on. What we have done? We have passed this element. We have passed this variable. Likewise, structure variable can also be passed to a function we may pass either the individual structure element or the entire structure at one go, right? So how we are going to do that? Again, we have declared a structure of type book, and this the variable of a structure, say b1, right? Now I'm calling a function display b1.name, b1.author, b1.pages. So what we are doing here? We are passing the base address of the array name, because name is what? A character array, right? Then author, again character array, and then b1.pages, right? Because we are passing the base address that's why we need to take the character pointers over here, fine. So that's how we can pass the structure elements or the structure variables in a function, fine. In the last example, we have passed the structure elements one by one, like b1.name, b1.pages, b1.price, and so on. And here we are passing the entire variable at a one go. We have initialized the values of this variable b1, and then we have passed b1 to this function, and here that's why we have to take a structure variable here as well, fine. So simply we can write this variable dot name, author, and pages, right? So next we have pointer to a structure. We can have a pointer pointing to integer or a pointer pointing to a character. Similarly, we can have a pointer which is going to point to a struct or a structure, right? Like again, if I take the same example, and here I have taken a pointer variable. Which type of pointer variable it is? It is of type struct book, right? That means it is going to have the address of which type? Struct book. Struct book, this is the data type. This is a variable, these are the values, right? So because it is a pointer variable, now I can assign the address of this variable to this pointer variable. That's why we can write ptr is equal to address of b1, fine. So b1 dot name, b1 dot author, b1 dot pages, that is what? A structure variable dot name, structure variable dot author name, structure variable dot pages. And when I am using pointer variable, then we have to use this arrow operator instead of dot operator, okay? So ptr, that is not a structure variable, it is a pointer to a structure, and dot operator requires a structure variable on its left, okay? So C provides an operator, this arrow operator, which is used to refer to the structure elements, right? ptr, arrow operator, name, right? Then pages, then author name, and then pages. And here these are the references from where I have taken the contents in my slides.